Hi, my name is Teresa, and today we're going to talk about solar sails. A solar sail, also called a photon sail, consists of three main components. The first is a highly reflective, thin surface, such as an aluminized plastic like mylar. That's what I chose because it was a rather cost-efficient method for a solar sail. Also, you need the photons in the sun's light to push the sail when you're in space, because the photons in the sun's light hit the sail and apply force, and this constant pressure causes a constant acceleration. And although when a rocket's in space, it decelerates from the gravity of the sun pulling it back towards it, a solar sail will actually accelerate due to the constant pressure of the photons. However, a solar sail can't get into space without the last component, which is a launch vehicle. Now, once the solar sail's in space, before that, obviously, you don't want to send a sail up there without calculations being done. But I use this formula, FSR, which is the force contributed by solar radiation, equals negative PSR, which is the force per unit area exerted by solar radiation. And it also uses the coefficient of reflectivity. And since I chose mylar, I chose 75% reflectivity because no object is fully 100% reflective. And the area of the object, which is exposed to the solar radiation, is also key, as well as the radial unit vector between the object and the sun. So it's just basically where the solar sail is in comparison to the sun. And basically, I knew that the value for FSR, which was at Earth, it's 9.15. However, at Mars, it's about 3.96, and it's a declining rate, right? Because as you're going from Earth to Mars, you're going to have less and less because it's dispersed over a greater area, which is why I use the inverse square law. The inverse square law is a declining rate formula, and you can do it based on distance or time. So, basically with this formula, I know all the values except for PSR. So then I manipulate the formula to calculate for it. And also, I discovered that the sails would be leaving Earth at an angle of 19.93 degrees. And I determined this by using the Earth's orbit and the required escape velocity, along with Earth's orbital velocity, and used a primary trig ratio, and was able to come up with the value of 20.53. However, that's not the exact angle, because as shown in my other video, you have to calculate for the Earth's eccentricity, because Earth's orbit isn't fully circular, it's actually an ellipse. So to compensate for this, I'd multiply the angle I discovered, the 20.53, by 100 and divide it by 103, which gave us the 19.93 degree angle I talked about earlier. And another key to the solar sails would be knowing when to drop the sails, because as I said in my last video, to be caught in a stable Martian orbit, I determined that you need to be going at a velocity of 24.33 kilometers per second. But if you drop the sails, you're going to decelerate because you no longer have the constant acceleration. So I determined that after 37 days, I would have to drop the sail because basically you keep accelerating and you'd actually have to use fuel to decelerate, whereas if you just drop the sail at a certain point, you can actually, the sun decelerates for you, which is a very cost-effective method. And you're probably wondering, okay, well if you're only going about 1.4 kilometers per second faster, why bother going to all the trouble with a solar sail when you could just use a rocket to get it there in the first place? Well, I actually looked it up, and a solar sail would only cost about $1 million. However, the fuel required would be approximately 33,600 kilograms of fuel, which would cost a lot more than the $1 million sail. And from there, I calculated how long the mission would take by calculating the distance as well as use velocity and distance and time, and I'm able to calculate how long it would take, which was approximately 197 days. However, I'd have to add the 37 to it, which would give me approximately 234 days for the entire mission. And 37 is important because that's when we still have the sail, and after that you cut the sail free. So thank you very much for listening, and have a wonderful day.